Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello, dear students. Welcome back once again to this TV learning programs. I'll be with Senior 3 today, the chemistry of Senior 3. We are still looking at unit number 7, which is concentration of solutions. And this is lesson number 3. You remember we had talked about how to prepare solutions, and we talked about the units of concentration. We talked about, in the preparation of the solutions, we mentioned about the 2 methods. I hope you still remember. The dissolution method, and we talked about, which we said, the dissolution or weighing method, or dilution, or another one was the dilution method, where you have a higher concentration of the solution and you dilute it to a concentration that you need to use. So today we are just going to look at the calculations involving the number of moles, molarity, and the mass concentration. That is our lesson of today. So please, I invite you to get ready, have your book and pen. You may need a calculator. Actually, you need a calculator. You may not, let me say you may. You need a calculator. You need a periodic table with you. So please pick a calculator, pick a periodic table, and then we go on. So by the end of our lesson today, you'll be able to calculate the moles, of course, because we said it involves the moles, involves molarity, and mass concentration. So you'll be able to calculate the moles. I believe for the moles you have done it even before in Senior 2. So this is like a continuation. But we looked at the moles with, in relationship with the mass in Senior 2. So this time we are looking at the moles in solution of the substances in solution form. So you determine the concentration of the 4 of the solutions in moles per liter. You remember we said that is molarity. The moles expressed in 1 liter, that is molarity. You will determine the concentration of the solution in grams per liter. So you'll be able to change those moles in moles per liter to grams per liter. That is the mass concentration. Mass concentration. Grams per liter is the same as mass concentration. Moles per liter is molarity. Then you'll be able to calculate the mass of the solute that is used to make the solutions. Since we'll be able to have to calculate the moles, then we'll convert the moles into the mass to get the, depending on the solution that we want to prepare or that we want to use. You will determine the volume of different solutions given other known quantities, either the concentration, either the moles, so you'll be able to determine the volume that is contained in a given solution. Let's go on. So in part A, calculate the number of moles of solute present in the following. Please be ready with your calculator. Calculate the number of moles of solute present in the following. Part A. That is Roman number 1. So you have Roman number 1 of part A, whereby you are given the volume of the solution, which is equal to 100 cubic centimeters solution. And then 1.5 molar, that is, when we say molar, that is molarity. So you are given molarity. Molarity, which will be equaling to 1.5. This is moles per liter, or molar. That capital M indicates moles per liter, the number of moles in 1 liter. What are we asked to do? We are asked to calculate the moles of the solute. So the moles of this of the solute of sulfuric acid. So we have the volume. So if we are calculating the number of moles, we know that molality is equal to moles times the volume. The volume must be in liters or decimeters cubed. So what does this mean? We need the moles now. Now, how do we get the moles? So the moles will be equaling to molality divided by the volume, but you remember the volume must be changed into liters. So what is this now? Just substitute in. You have the molality, which is 1.5 moles per decimeter cubed. This is 1.5 divided by the volume is 100. But I said the volume has to be changed or converted into the liter. So that means it will be 100 times 1/1000. So we need to convert this into a liter. So that's why we divide 100, we multiply by 1/1000. So the volume that we will get here will be the volume will be in liters. So this will be equal to 1.5. When you divide 100/1000, just zeros, that is 1/10. So 1/10 is the same as 0.1. So when you divide that one, get your calculator. Just press your calculator and see the answer that you are able to get. What is the answer that you have? So when you get the calculator, 1.5, you divide it by 0.1, you are supposed to get 15 moles. This will be 15 moles because we are supposed to calculate. This is the answer that we have. So part 2. Part 2 is saying 20 liters, that is the volume of 2 molar ammonium hydroxide. So let us go to the part 3. I just leave part 2 for you to attempt. Just write part 2 and you'll try to attempt it. So let's go to Roman 3. Roman 3, a solution 600, we are given volume, and then we are given the mass. The mass that we are given is in, so we need to convert that mass into the moles. So remember always this. Remember this. This is very, very important. The moment you have this, so you can get the volume, you can get the molality, and this time we are given the volume. So the volume of the solution, volume of barium chloride solution is equal to 600 centimeters cubed. And this 600 solution contains the mass in 1 liter. So it contains 41. So what is that one? That is the mass concentration. That is mass concentration. Mass concentration will be equaling to 41.6 grams per decimeter cubed. So what do? We are given mass concentration, but we are given, so we need to first change it into moles. How do we get the number of moles? So that we get the molality. So here we say molality this is another important formula that you need to remember, will be equaling to mass concentration. The mass concentration is given in grams per decimeter cubed, divided by the molar mass. The molar mass. The molar mass is in grams per mole. So that means we need the molarity here. So what we're going to do, we'll need the mass concentration is given, that is 41.6 divided by the molar mass of barium chloride. That's why I said you need a calculator. So the calculator, barium chloride. So you need to find the molar mass of barium chloride. When you look at your periodic table, you'll find the atomic mass of barium is 137. So you'll add 35.5 times 2. So this is the same as 137 plus 71. So when you add that one, this is 8. You add 3 and 7, that is 0. That will give you 10. Then you remain with that one plus 1. That is 208 grams per mole. So after getting the molar, so we are getting this one, divide by this. So we divide by 208. So this will be, now when you compute that one, what do you get? Still, I said you need the calculator very close to you so that you always place it with me. So you have 41.6 divided by 208. So you are getting 0.2. This is equivalent to 0.2. This is moles per decimeter cubed. This is the molarity. Why are we looking for the molarity? We need to use this. So after getting the molarity, then we substitute in here. Molarity, we have in this one, we have said molarity again is equal to moles. Remember, we are calculating the moles times volume. Remember, when you are using the volume, it must be in liters. So molarity, you have 0.2. This will be equaling to the moles. That is what we are calculating, times the volume, 600 over 1,000 to convert it into decimeter cubed. So our moles now, will be equaling to 0.2 divided by this. This one will be, when we cancel this one, 6 over 10, that is 0.6. That is 0.6. So what do we get? Again, you need your calculator. 0.2 divided by 0.6. That is 0.333. That is 0.33 moles. So let's continue the calculate the number of moles of solute. This time we are given, isn't it the same as what we have finished? Almost the same, because we are calculating the number of moles. We are given molarity. So I will attempt 1 for part B, and then the 2. You do the 2. Molarity still, number of moles, the same. We said moles is equal to volume. When you look at this, we said moles is equal to molarity. Sorry, is equal to molarity divided by the volume. Always the volume must be in liters. So what is that? So you have the volume, which is the molarity is 0.5 divided by the volume. Volume is 100. So 100 over 1,000, because we said it has to be in liters. So converting from centimeters to liters, you divide by 1,000. So if you cancel this and this, so what is that? You are remaining with 0 point, so this is 0.5 divided by 1/10, which is 0.1. So this one will be 50 moles of silver nitrate. This is 50. Let's compute with the calculator to be very sure. 0.5 divided by 0.1. Oh, it is 5. This is 5 moles. You are getting 5 moles. The same way you do with the rest. So if the volume is in decimeters cubed, you don't need to divide, because like for the last one, you see it is 5.4 decimeters cubed. Don't divide by 1,000. Why? Because it is already in liters. Remember that 1,000 cubic centimeters is equal to 1 liter, which is equal to 1 decimeter cubed. So that is the same. The moment you have decimeter cubed, don't divide, like that part 3. Don't divide by 1,000, because the volume is already converted. Let's proceed. Determine the concentration of the following solutions in moles per liter. So that means you need molarity. If they say moles per liter, you need the molarity, period. You have the volume, but you have the mass. So since you have the mass, you need to get the number of moles. You need to convert those ones into the number of moles, because here in this one, we don't have the moles. So if we are looking, we are having the mass, which is, that is part C. When we look at the part C, let's attempt part C, Roman 1, whereby you have the volume. The volume is equal to 250 cubic centimeters, and you have the mass, which is equal to 2.46 grams. So you need now to look, you need to convert this one into, because this is the mass that was in 250. So we need to look for the mass that is in a liter. That is the concentration, the mass concentration. What do? We need to first get the number of moles here, and then again get molarity. So the moles of this compound, magnesium heptasulfate. So there, this one, magnesium heptasulfate, it is written like that. So we need to get the number of moles of this. So that will be moles, you remember from your senior 2, moles is equal to mass over molar mass. Mass over molar mass. So after getting the moles, we have the mass that is 2.46. We'll divide by the molar mass of all this. How do we get the molar mass? We'll add the atomic masses. So that is why your calculator, your periodic table is very important. You don't need to memorize the atomic masses of these compounds. You get them from your periodic table. Magnesium, when you check on your periodic table, magnesium is 24. So we'll add sulfur, which is 32. You'll add oxygen, which is 16 times 4. 16 times 4 gives us how much? It gives us 64. Plus, now this is 7 times 18. So the whole of this one is 18. 7 times 18. So we add. What do we get? Your calculator, once again, is needed to compute that. So 24, so we'll start with 7 times 18 times 18. That gives us 126 plus 64 plus 32 plus 24. What do you have? I have 246. This is 246 grams per mole. Remember, molar mass is measured in grams per mole. So get the number of moles here, divide by 246. So this will give us 0.0. Compute to be very sure. That is 2.46 divided by 246. That is 0.01 moles. After getting the number of moles, we are supposed to calculate moles in a liter. So how do we get that? We said molarity, that is molarity. When we talk about the moles, remember we are referring to the moles in a liter. So that is molarity, which is equal to the moles times the volume. But you remember I said the volume must be in liters or must be in decimeters. So we have, now what we are looking for is this. Because we have the volume, we have the number of moles calculated, 0.01. We have the volume, which is 250. 250. The volume has to be in 1,000. So we have to multiply it by divide it by 1,000. So the answer here we get 0.01 times, that is a quarter. A quarter is equivalent to 0.25. That is 250 divided by 1,000. Is it 250? No, not that. 250 divided by 1,000. That is 0.25. 0.25. So the answer we are getting here will be molarity, which will be in moles per liter. 0.01 times 0.25, which gives us 0.04. 0.04 moles per liter, or the capital M. Capital M. So the way we attempted this question, that question number C from here, you can be able even to attempt those two questions because I've given those two questions. Look at those two questions. Try them. 600 cubic centimeter solution containing 6.8 of zinc chloride solution. The molarity. 500 cubic centimeters of solution containing 1.06 grams of sodium carbonate. It is the same. So you need to first get the molar mass, converting the mass into moles, and then use the formula, which I said here. So remember as well, this one also, remember this, very important. So remember that one. This is molarity related to mass concentration and molar mass. This is how molarity or molar concentration is related to moles and volume. Let's look at part D. Determine the concentration of the solution now in grams per liter. This is where this formula is very important. So Roman 1, Roman 2. Let me go to Roman 3. I'll just leave Roman 1 and 2 and 4 then for your attempt. I just go to attempt Roman 3. Roman 3 of part D. 320, that is the volume given, 320 cubic centimeters. We are given the mass, which will be 9.36. 9.36 grams. So what do? We need to first look for change this mass into the moles, or we can say this mass was in this one. So we look for the mass. No, this one, then we look for the mass in 1 liter. Or we apply the formula there. So if we change this, we will get the molarity. Change, let's look for the moles, which will be the moles 9, which is 9.36. Number of moles is equal to mass over molar mass. Sodium carbonate, when you compute sodium carbonate and get the mass of sodium carbonate, 1 mole of sodium carbonate, 23, that is 46, plus 12, plus 48, you'll get 106. So this will give us the number of moles. Your calculator once again. 9.36 divided by 106. That is 0.088. 0.088 moles. After getting the number of moles, what are you looking for? You are looking for, now you have the volume. We need the molarity. Molarity will be equaling to moles times the number of moles times the volume. You have the volume already. You have the moles. So here the number of moles is 0.088 times the volume. The volume is 320 divided by 1,000. So after getting the number of moles, that will be the molarity. Then substitute in here. After substituting here, you have got the molarity. You can use the molar mass. Now you can determine the mass concentration, the concentration of the solution in grams per liter. Because when you're talking about the mass concentration, we are referring to the grams per liter. So we're able to calculate the number of moles when we are given molarity and volume. That is one. We're able to calculate the number of moles when we are given either molarity or the mass concentration or the molar mass. Or you can calculate the mass concentration, when you are given the molarity alone, as long as you know the compound that you are, the substance that you are using. 2 molar sulfuric acid. Thank you so much for being with me in this 30-minute session. I hope we've been together. Hope to see you in the next lesson. Bye.